All right, so in our first graph of force versus distance, we had like force and distance, like this. And we got this exponential relationship that was, okay? And then that is an inverse relationship. It's proportional to 1 over d or something, or 1 over d to the n, I guess you'd say. And so after testing it, we have determined that the best relationship between force and distance was 1 over d squared. And I think, did your data look like really close together and then it got kind of further apart? Like that? Kind of looked like that? Yeah. And so that gives us a nice straight line to linearize the data. And so that tells me that this force, and it's not just any force, it is the force due to electrons, right? It's the electric force. It's due to there being extra electrons or fewer electrons. And it's proportional to, so the little proportional symbol looks like a little fishy, 1 over d squared. Now, big boy, big girl physicists don't call it d, they call it r squared, and that's what you'll see on the AP exam, the 1 over r squared. And r just represents the distance between the two objects, just like the universal law of gravitation. Now, so let's look at that. We'll look at our little comparative. There we go. So our gravitational force was big G, m1, m2, over r squared. Now we see that the electric force must be equal to something divided by r squared as well. So instead of it being mass that's attracted to each other, or in this case, attracted or repelled, what were those things that you manipulated in the simulation? The charges, Q1 and Q2. Now, unlike mass, charge can be positive or negative. And if we're solving for the force, we're solving for the magnitude of the force. I don't care if it's left, right, up, down, or at 45 degrees. That will give you the magnitude. So I need the magnitude of the charges. So we take the absolute value of the charges. So Q1, Q2 over r squared. And I write my Q's like they are cursive. So if you want to write old school Q's, I don't care. It's up to you. Okay. And then in place of the G, we've got to have a constant. It's just the way it's going to work. And what's cool about this is that in nature, there are many things that behave as this 1 over r squared, with this 1 over r squared relationship. And we call that constant, it's the symbol K. It is Coulomb's constant, sorry. So let's see. So F is the electric force. What would the electric force be measured in? What's the frictional force measured in? What is the gravitational force measured in? What is a pushing force measured in? So what's the electric force measured in? Newtons. A force is a force, of course, even if it's electric force, of course. Okay, Q1 and Q2. So like M is the symbol for mass, Q is the symbol for charge. Oh, that got ugly quick, didn't it? So pretend like that says charge and it's real pretty. So charge is measured in coulombs. R is the distance of separation, just like for planets. And what are we going to measure distance in? Meters. And then this Coulomb's law constant is, so this is Coulomb's law. And it's 9